Hi,
Oh, hi, Christina. How are you?
I'm good. How are you?
Oh, good. How are you doing? Do you have any questions about anything or any that you
Um,
specifically want to go over?
um, Let me just check because I got like five out of the nine in the. Let me just see modules.
So they're not as bad as it seemed, right?
No, no, not really at all. They're pretty simple. The first one is easy. Second one is really easy too. Here, let me look at this because I'll tell you which ones I'm like good with. I'm
Okay.
good with question one, two, and three, and then eight and nine are very simple. And then
Okay.
question four, I know it's probably a bit different because we're probably using a different the I forgot when it's like SSA, SSS, the name, the term.
Right.
Yeah, but four, five, six, seven, I think they're probably all still alike compared to question three. So I
Yeah. So let's go. Let's start with like five. Then, like, I know I did one like four, but I I do know that like sometimes like the when the numbers like change the it might like make the problems a little bit different, you know.
yeah.
So I will say though that I do want to talk about something on the homework though real quickly because it has to do with the one of the homework problems where it was the last one in section 9.3. And so the issue is that if you look at the online book, the problem will be here, I'll show you. Okay, this was what the problem will be. So I I just want to like point this particular one out because the the issue is that the online book, like if you have the printed book for whatever reason, it does show this, but the online book doesn't give the image. And so it might be a little bit hard to, figure out what's going on if you don't have the picture there to help you. So I just wanted to make sure that you like saw the picture for that one. But I also will, because of this, like I'll just see here. Let me see if I can actually like print this, like at least like set it up for you so that you can see like how I might actually do the problem, but I don't know why I can't get it to like, okay, let me just try to print this real quickly because it is like the ones we've been doing, but when the diagram is a little bit more difficult, it can cause problems. I, so I'll make sure to do that one, but oh, here it comes. If it wasn't going to print right away, I was actually going to do a different one first, but
I had a question about the homework assignments actually.
oh,
How is
yes.
how is the grading system for that? Like, does it like
So the grading is that it is, I don't want to say the wrong percentages because it, it's, let's see, where is so yeah, I really, really wish I could have the grades like go into Canvas like every week, but the BVT lab just is really, really like hard to make that happen. So it would make it actually look like your grade is lower than it actually is. So
Yeah.
it would be, so like every homework is worth 7 points at 42 points, but it's only counted out of 36. So it's like then you can get 42 out of 36. So you can actually get 117% on the homework. So that just means, right, if you don't like do as well on one of them, or even if maybe like uh since it's 6 points dropped, like you could just maybe not do one of them and still get 100 close to 100%, as long as you got 100% on all of the other ones. But if you want like the few extra points, then it will be good to do that. So then there are up to it says that there are 400 points possible, but you can get 16 extra credit points. So you can get 416 out of 400 is a maximum. So there actually you can get up to 104% total. So like I feel like at that point, even though it might not seem like there's a lot of points overall, like 104% is quite a lot of extra credit, So like I don't think that like if you are doing everything like that, you can't get a decent grade,
Yeah.
So
For the homework, I mean, like, I don't know why, like, the book, I feel like I don't really do as well in the homework as I should. So I'm like kind of nervous it'll drop my grade a lot, but I think I'll be okay.
yeah, so I don't know, like you, if you email me, I can look and see, but like I don't think it will be a big problem. I really don't, but like I like if it happens to be like the homework like dropped your grade a lot, uh I'll look at it at the end of the semester, because I know like there are little things like this, like the diagram missing or things like that that make the homework a little bit harder than it should be. So I I do like curve it up a little bit, So if you really think that you will have a big issue, then just let me know,
Okay, perfect.
But for this one, all right, so here's how this is actually working here. So you have the now the thing is that the like depending on what how you draw the diagram, this can be a bit of an awkward thing to do, but you yeah, I do think that this can, like, I'm not even sure why. Um, yeah, I think that this could actually be seen as honestly, like a, how do I say this? Like a little bit misleading because, yeah, this is a little bit misleading because I see the diagram there, and that's not actually the diagram that I drew because let me see, because I know what the answer is, and that's what bothers me even more about this is like I was sent this diagram, but I just want to double check that it's not like what I think that it is. So it will be let's see. Yeah, so that's not actually quite right. So this is a this is a in my opinion like a very bad diagram because the so all right, the hill makes an angle of 10 degrees with the horizontal. So the the horizontal is right here, and then the 10 degrees is right here, and then I you see the wire right here. So I really I I don't want you to think that this is actually like a like um how do I say this? Like that this is 90 degrees right here because it's not, because this is going at angle. So what actually is happening is something more um something more like this. Like this is straight up in the air. So this is actually the 90 degrees right down here. All right, so this is like straight up in the air. This is actually the ground, and this is the hill with like sort of grass along it here. So then it's very tempting to like say that this is the 90 when it's actually not 90 because this is a hill. And so then this angle right here, since this is 10 and that's 90, will be 80 degrees because you have, right, uh, alpha plus beta plus gamma is 180 degrees. So then you have the 10 plus 90 plus the missing angle is 180 degrees. So that missing angle is actually 80 degrees. And so then these two are supplementary angles. So then that would mean that these two angles would need to be totaling 180. So 180 minus 80. Actually, did I say 80? I did say 80, right? Would be 100. Yeah, would be 100 degrees. So then that would be 100 degrees right here and not actually 90 degrees. So then the triangle that you actually need to do the problem would be this one right here. And so the problem is that you have this triangle like this, where it's 100 degrees and then 50 feet here, and then 30 feet here. And then this is the like missing length of the wire that you want to find. So if you want to find the missing length of the wire, then that would be in this particular triangle. It's a side, and then the angle in the middle, and then a side over here triangle. So SAS triangle. And oops, sorry, you can't see this. I don't know why it didn't move down like I said. So then it's a SAS triangle. And so then for an SAS triangle, that's when I had that cheat sheet where I I said, well, for SAS triangle, you're going to use law of cosines. So that means you're going to use law of cosines because it's SAS. And so it doesn't really matter how you label these, but if you call this one, say, A, B, and then C right here, then use the formula that says C squared is A squared plus B squared minus 2AB cosine of gamma. So C squared would be 50 squared plus 30 squared minus 2 times 50 times 30 cosine of 100. And then if you do all of that, then as long as you have it in degrees, you should get 50 squared plus 30 squared minus 2 times 50 times 30 cosine of 100 is C squared is 3920.944533. And then take the square root of that, and that will give you your answer. So C is about 62.617444592 feet. And then you would just round it to whatever number of feet that it is. So, I don't think that this is too bad, but that's an example of an uh SAS triangle. So you have any questions?
No, I don't have any.
Yeah, like I said, I don't think that this will be too bad for you, Christine. I just feel like you have to see it a couple of times. And then if you want another one just to practice, like this is another one that I found that but they draw the diagram in a way that I think, in my opinion, it makes a little bit more sense. But like it's just a mirror image of it though. But I think that it's really hard to see that this isn't 90 because of how it was drawn here, because it was drawn more at angle, like it's more obvious it's not 90. So that's why I have a little bit of an issue with that one from the book. But I talked to the guy who wrote the book, so he knows that like the diagram is missing from online now at least. So let's see, number 5 then. So number 5 is just then solve the triangle with gamma is 38 degrees, beta is 32 degrees, and A is equal to 19. So I really don't think that this one should give you too much trouble, but let's see what we have here. So I will just go ahead and draw the triangle just before, and like before, and this is just a generic triangle, so it might not be to scale. So alpha, beta, gamma, A, B, C. And so gamma is 38 degrees, beta is 32 degrees, and A is 19. So I want you to see that it is an angle side angle triangle. So it's an angle and then the side between them and then another angle. So ASA triangle. So for the ASA triangles, then that is this case where we use the law of sines. So use the law of sines. Now, then the visuals are in the other one right here, the ASA like that. So now what I will say is that the alpha is easier to find, so always like try to start where you can with the easiest one to find. So alpha plus beta plus gamma are equal to 180 degrees. So we have alpha plus 32 degrees plus 38 degrees is 180 degrees. And then if we total that up, we have alpha plus, what is that? That's 60, 70 degrees is 180 degrees. So alpha is 110 degrees. So 110. Now, then since now you want to find the B, but remember that if a side is missing, then you probably will be better off like using this set of formulas. So if a side is missing, then use the A over sine of alpha equals B over sine of beta equals C over sine of gamma. And so then what do you already know? You know the beta is 32, you know the gamma is 38, and you know the A is 19, and you know the alpha is 110 because you just found it over here. So then you only need this part of the equation to find the missing B over here. And then what you're going to do is that then when you go and find C, then you're going to say, well, A over sine of alpha is C over sine of gamma, since these are the ones you already knew, and this is one that you, right, one of the ones you didn't know. So then just substituting the numbers and solve, and it is not hopefully too difficult. So A was 19. So 19 over sine of 110 degrees equals B over sine of the 32 degrees. So if you do this, and again, like, so I would just write out the numbers so that you don't have any issues, especially since the problems aren't asking for exact answers. And from a practical sense, you don't really need exact answers here. So because otherwise it doesn't really have any meaning to what the what the situation is. So 19 over sine of 110 degrees is 20.219377768. And then this is B over sine of 32 degrees is 0.5299192642. And then if I sorry, I'm going to turn that light on a little bit. And then if I multiply those two numbers together, so that times that number, then B is about 10.714637774, or to two decimal places, just 10.71. So that is actually, that's not too bad, actually. Do you have any questions? Okay, so then the next one right here is actually, let's see. So what do we have? We have 19 over sine of 110 degrees is C over sine of 38 degrees. But I will say that the good news about writing this out this way is that this number is just a repeat of, right, that number up here. So you only have to really do one number. So 20.219377768 is equal to C divided by sine of 38 degrees. So 0.6156614,753. And then C will be approximately, if I multiply those numbers together, the 20.219 number times that 0.615 number, I get it's about 12.44829,189, or about 12.45. So nothing really, I wouldn't say like too difficult, but just sort of remembering which of the cases you have. So, do you have any questions?
No, I don't have any.
Okay, so then let's see. So this one actually is. All right, so then number 6 is actually one where this is. All right, so number 6 is. Oh, I don't know why this is actually like this. Number 6. Okay, so this one is to solve the triangle with the. So solve a triangle with A is 62.22, B is 20.27, and beta is 46 degrees. So then for this problem here, what happens is if I draw the generic triangle again, and it just is like this, and then my alpha, beta, gamma, and then a B, and a C. All right, this is 62.22. This is 20.27, and this is 46 degrees. So what I have here is a side angle. Now, yeah, I it's side angle, so it is SSA, and so then I want you to remember that this means to use the law of sines, but this is also the ambiguous case. So that means it's the harder case where there could be 0, 1, or 2 solutions to solving the triangle. So this again all depends on uh, it depends on a lot of things, but the most basic like breakdown of it is just, oh, by the way, this is actually uh this actually this box I put on the in the notes from the other day actually has the information that you need, but I'll do it like right here since we didn't have one like this the other day. So what you need to do is calculate the altitude or the height. So the altitude or the height of the triangle. And so then that is step 1. If you, well, actually, step 1, right, is actually identify the type of triangle. So I feel like that is always step 1. And then step 2, determine whether to use the law of sines or cosine. So that is actually step 2. And then step 3 will be, all right, in the ambiguous case. So if you have the ambiguous case, then you need to calculate the, the other thing is that the all right, so yeah, you have to actually make sure that uh the yeah, I feel like this is actually I think I didn't draw the triangle wrong. I think I probably drew the triangle wrong. Well, yeah, using the same triangle as before, but I feel like my height of the triangle is actually, yeah, my height of the triangle is actually it's a yeah, my height of the triangle is actually different than the one in the, it's different than the one in the um yeah, I want to double check that it's the same one. Yeah. Oh, yeah, that's not the height that you want. I drew the, I mean, it's the right height, but I mean, it is the height, but that's not the height that you want. So like, you're not gonna measure it from this direction is all I'm getting at. So it is how tall the triangle is, but you need to measure it from if this one was like this one was the flat one, and then you're actually like measuring sort of, if this is the flat side, then like you're measuring, I know it's really hard to see, that's why I'm like you need to like make sure like if this is flat, then you're measuring like from here to like from here to, actually why am, this is what I mean, like I don't want to like mess it up for you, but I, so let me, I know what I'm gonna say, but I want to draw it so that if you go back and look at this page right here, you'll see what I'm talking about. So these are the, okay, so these are the 3 pieces of information that you are given. So yours are actually, instead of A and B, like alpha and then beta. So then if I draw it so that you have the, and then gamma up here, the alpha, and then the gamma, and then the beta is 40, actually. I know why this is actually the way that it is, but I'll tell you right now. But anyway, if you have it like this, 46 degrees, and then the B side is the 20.27 degrees, sorry, it didn't say inches, but, and then the A side is 62.22. It's still the same idea, but because this angle is actually the one that is missing, then you have to do something a little bit different. So this is when they say specifically, right, the given angle alpha is acute. So then that's what you do. So this right here is only if alpha A and B are given. But if you have one like this, if the beta A and B are given, then you are going to do something, do something else. So that's why I'm saying this, is that I don't want you to get the letters mixed up. So that is, if the beta A and B are given, then if the triangle is SSA and beta is acute, and then the B is less than the A, then if the B is less than the altitude, then right, no solution, and B, and this would be, then the altitude would actually be the A sine of B. And then if B is equal to the altitude, then there's one solution. And then if the B is greater than the altitude, then there are two solutions. So that's what I'm really like talking about here. But I feel like the notation, whenever anyone tries to generalize it like this, they give you a bit of an issue here. So I don't really necessarily, I guess, want you to like remember the letters as much as I want you to remember that then in this like ambiguous case problem here, then if you want to generalize it, then the triangle must be SSA. The given angle is acute, and then what you would say is not just necessarily A is less than B, but that the length of the side across from the given angle is less than the other side given. So the length of the side across from the angle is less than the length of the other side, the other given side. So that's how you would generalize it. So this would be the side across from the given angle beta in this case. And then the altitude would be then the length of the other side, the length of the other side, and then times the sine of the given angle. And then you would just apply the rules for whether the length length of the other side is less than the altitude or length of the other side is actually equal to the altitude, or the length of the other side is actually the greater than the altitude. That would tell you whether you have the no solution, one solution, or the two solutions. So I don't want to make this worse, but I really think that it's worse if you, right, if you use A or B and then you mislabel it, right? So I think that like writing it out in words, maybe like, well, all right, this is the angle, that's the across from the given angle, and then that's the other side. Just calling it other side then is a little bit easier here. So do you have any questions before we do the calculation? Okay, then let me see. I'll do the calculation on this page then. So, all right, B was acute because it was 46 degrees. And then this is less than this. So I know that was true. B is 46 degrees, true. And then the 20.4, or sorry, 27 is less than 62.22 is true. So then I need to find the altitude. So that will be the A sine of B, so 62.22 sine of 46 degrees. And if I do that, then I have 62.22 sine of 46 degrees is actually equal to 44.75732238. And then since the B, all right, so since the B is less than the altitude in this case, so B is the 20.27 is less than the 44.75732238. That means therefore this has no solution. So this one has no solution. So I do think that this can be a little bit tricky, but I don't think that it's actually like the worst, but I like to give you, like, do one where there are two. Yeah, I would like to give you like an example. Oh, and by the way, I don't think that this is actually as clear right here, that this is a cutoff if the, like this box right here, this should actually be like two different boxes. It's more like these are the cases if the triangle was, or the given angle was acute, and these are the ones where the given angle is obtuse. So that's what I really just want you to like notice, is that, right, if it's the given angle is obtuse, then there's only like two possibilities. That you can't actually have two triangles, but you could have no triangle. So that's why I think it was important to be like, well, yeah, this was 46 degrees, it's acute, so it has to be one of these four things and not one of those two. But the problem is that the uh I didn't, I wanted you to see the one, at least one of them where there's like two triangles, and I don't know where I have to find another one, because it just like, that's the type of thing where Yeah, let's see. So let me find another one. It was number. Uh, hmm, no. Yeah, I feel like this is one where it if I go and I like do this over and over again, then it's just gonna give me like I hope it doesn't. Like it said that I could do this again, and it. Yeah. Oh my. Hmm.
Um, I think it's okay. Is it a different like question where it has two triangles?
Yeah, I'm looking. I was looking for one, and I don't. Yeah, I really would like to find another version of it, like just so that I can like show you one because I know that like if you do the practice quiz that okay, let me see if I can get another version because like it might like it's actually very odd that it like sometimes will give me another one and then sometimes it will won't and sometimes it will and I don't oh okay then this one is actually yeah I don't actually know why like I was looking for one where it give me one where it is an obtuse angle, but I don't actually know if now that I think I'm looking a little bit more carefully because I have to keep on refreshing it for this to like do what it's supposed to. So yeah, that's why I'm having a bit of an issue with this one because it's actually it's like shuffling them around on me. So like that might be why like you had the one where it wasn't like my number 5 was different than your number 5 the other day. So yeah, okay. I don't oh my. I don't know why it's not giving me one. So
Um,
here here let me just make one up then because I don't know why it won't just give me one. So I'm making one up. So let's just try this one. I hope that this one will work. So nope, it's not gonna. Oh no. All right. Here's one. Uh actually, you know what? Okay, here's one. So here's an example. So let's say that you end up having something where you are given that the A is equal to 10.2, B is equal to 8.7, and then beta is equal to 55 degrees. So it looks sort of like that right there. So then here is, and this is actually might be a better, now that I see it, like I have a better image for you than what I had before. So I'm just gonna like uh give you this other one in a second, but I don't know why I didn't just like look for it before, but I just didn't want to do that one right there, but here it is. So there's so much other junk on the internet, I'm telling you. So, all right, if I do this one very similarly to the last one and I set up my triangle the way that I usually do, so alpha, beta, gamma, C, A, B. So A is 10.2, B is 8.7, B beta 55 degrees. So then this is actually, again, angle, side, side. So side, angle, beta equals 55 degrees is actually acute. And then the 8.7 is actually less than the 10.2. So then you know that this is the ambiguous case. So all three of those things have to happen for this to be the ambiguous case. And so then therefore, remember that you have to calculate the altitude. So the altitude is then, in this case, the A sine of beta. So then you have the 10.2 sine of 55 degrees. So 10.2 times sine of 55 degrees is about 8.355350852. And then since the B, so since the B equals 8.7 is greater than the 8.355350852, then therefore there are two possible triangles. So that is actually then the issue that occurs now. So what I think that the way that you have to do this, and just to be careful about this, like sometimes people will try to draw the triangles pretty much like you see the diagram. It looks like this, and then the angle that is here is at the top, and then you have the A, and then you have the B right here. So the issue is that when the what was I gonna say? Yeah, the angle that is over here, right? And this is gamma and this is alpha. So I'm just gonna write it like that. The problem is that this angle right here, angle alpha, that one can be acute or obtuse. So the one of the triangles will be for this being acute, and then the other possible one you will draw will have it being obtuse. So that's all you need to really remember, is that in one of the triangles, the alpha will be acute, and then in the other one of the triangles, it will be obtuse. So really that, yeah. So in one triangle, the alpha will be acute, and then in the other triangle, then the alpha will be obtuse. So that's really like all you need to remember. is that that's how it will work. So if you like draw them together, then you get a like a really, I don't know, like I I will draw them on top of each other just so that you can see the issue. So let's say that you actually have like and this is what I mean. Like I know what people want to do. They want to they want to actually just like label these in really odd ways, but it yeah, they just want to label it in really odd ways because the height of the triangle is, if you remember what I said, the height, like if you have like this one right here, and that's the acute angle, and then you have one where that actually needs to be that needs to be obtuse, then it's how big does it have to be? That's the problem. It it needs to be like it needs to be like over here. Do you see like that's a smaller angle and that's a bigger angle? So that one would be the acute one, and that one would be the obtuse one. And then this right here, that's what would be the height H, or the height or the altitude. So that's why there's actually two triangles. So what you do is, if this is the beta is 55 degrees, and this is the A is 10.2, and this is the B is 8.7 down here. It doesn't, like, this is really like an odd looking thing, but it's just a matter of the fact that this is just the way that it's unfortunately unfortunately drawn, that this is, this is sort of like one of them will be obtuse and one of them will be acute. So then just go ahead and find these. So if you do this, then it's law of sines. So this was 55. This was 10.2. This was 8.7. So sine of, now since you want to find the alpha, then you would put the sine of alpha in the numerator. So over 10.2 is sine of 55 degrees over the 8.7. And then figure out what sine of 55 is over the 8.7. And then that will be sine of alpha over 10.2 will be 0.0941554074, and then multiply by 10.2. So then sine of alpha is 0.9603851554. And then inverse sine of that answer will give you, so inverse sine of the 0.9603851554 will be the 73.818795554. So that will be one of them. All right, and this is actually that right there. So that's the acute one, 73.82 degrees. Now, then if you want to find the obtuse one. Now, yeah, this is where I think that it actually is a bit like you have to, uh-oh, I was looking for that. You have to think about the quadrants again, because if you look at the quadrants again, and then you think that here was the 73.82 degrees, then you want the angle that is actually this other angle over here complementary to it. So 180 degrees minus the 73.82 degrees is about, yeah, that's 106.18 degrees. So this one right here will be the 106.18 degrees. So do you have any questions, Christina? Yeah,
Well, everything's pretty simple to be honest.
yeah.
Yeah,
So I
yeah.
don't think that this one is that bad, right?
No, no. The double triangles, there's a chance it will end up on the quiz, right?
Yes.
Okay. Oh,
So
it's fine.
yeah, so like, but at least you know how to check to see if it should happen. That's
Yeah,
what, like, I don't think it's that bad if it does. It's just you have to know how to check if it happens. I, like
yeah.
I don't think that it will be that bad for you. But
Uh,
I think you know the different cases now, though. So that's pretty much, I would say that would be it, because honestly, the if you did 8 and 9 with the area,
oh yeah, that I already did those. Those are
yeah,
very.
those ones are
It's like
literally like,
one half times b times c times sine is sine of the given like alpha
yeah,
gamma or beta. So it's pretty simple. And
yeah.
then
So like I don't think that those ones are that bad for
no,
you. So I'm
yeah,
not too worried.
yeah.
So
I just need to practice like four, 5, and 6 and 7. I'll be fine.
yeah, so if you do that, and I could do like 100 of them, and then you might still end up with one that might be like one of these cases where you just have to watch out for.
Yeah, yeah.
So I don't think it will be that bad for you, but
It's a shorter quiz, so I think I'll be okay.
yeah, so if you do end up having any questions, just
Yeah, shoot an email.
let me know. But I it is, you're right, shorter, so I don't think it will be that bad.
Yeah, it wasn't like the last quiz. Like the last quiz was not. It wasn't difficult, but it was just more to talk.
Yeah, definitely. Like I definitely will agree with that the last quiz was a little bit more. So if you get stuck, just as usual, just like feel free to let me know. But otherwise, like, yeah, I don't have any other specific examples because they're all very similar.
Yeah,
So,
yeah. All right.
but do you
Perfect.
have any other questions, Christina?
No, I just wanted to really just overview and then like that I'm all set. So basically, like I have no questions.
Yeah, so at least now, like I said, you've seen the one with the two triangles in case it comes up. Like
Yeah, yeah,
it might or might not,
yeah,
so it's unfortunate that it it might actually happen, but um I yeah, there's lots of different things. Like I haven't actually seen like a worksheet. I'd like to see a worksheet where they actually give you some actual like examples of each one rather than just the like the chart of the different cases, because I feel like sometimes examples are better than you can just
yeah.
like, like kind of follow the what do you call it, like the example and change the numbers a little bit. Wait a second. This is actually one where I think I see one that I might actually like. Yeah, I might actually give you this because this is actually. Yeah, I think I saw one that actually is one where it is might have all of the cases in it. So I might just uh yeah, I might just actually like give you some extra stuff if you need it at some point. So
Okay.
otherwise, yeah, that's it, Christine. I hope you